Hello everyone, welcome back to Easy Engineering. If you're new here, I'm glad you found the channel. This video is part of a YouTube course that covers how to use SOLIDWORKs for complete beginners. In this course, we reference this textbook by SDC Publications to cover SOLIDWORKs fundamentals, practical engineering workflows, and exercises to help you confidently prepare for and pass the SOLIDWORKs CSWA certification exam. If you're interested, I have posted links in the description to the textbook and downloadable files that come with it. If you'd like to keep up with the rest of the course and future engineering tutorials, consider subscribing, and if this lesson was helpful, leave a like to help support the series. Thank you. In this video, we are going to create this model from start to finish. The exercise will continue developing beginner-level part creation and modification skills by using the same design process from the previous video. For this exercise, we will begin with analyzing the reference drawing. As we can see from the reference drawing, we have three variables, variable A, B, and C, where A is 50, B is 50, and C is 120. Our units is going to be in millimeters grams second, so that indicates that A, B, and C are in millimeters. It gives us a material of 6061 alloy, and it has a density of 0.0027 grams per cubic millimeter. A few important notes is that we can see that the variable length C is going to be the length of our model, and then variable B will be the height. Variable A is going to be the width. Okay, let's go ahead and get started. Before we begin modeling, let's go ahead and take a look at where the origin is going to be for this exercise. If you have downloaded the exercise file from the SDC Publications website and you opened up the corresponding exercise for mass volume 3.5, you will see a part similar to this one. Mine is going to be colored, yours should be the color of the material that is assigned. Now looking at the origin, we can see if I can go ahead and highlight the origin here by pressing on the origin button in the feature manager tree, and this showing the origin at this location. If I go into the front view, we can see that the origin is going to be half of the length of our part. This assumption can be verified by activating the standard view planes, and as we can see, the origin is lying exactly on the right plane. And if we view the part from the left face, then we can see that the origin also lies on the front plane, indicating that it's going to be half of the length and half of the width into the part. Now that we have established the location of the origin, we can go ahead and begin modeling. Let's begin by creating a new part file for our exercise. Now that we've created a new part file, I'm going to go ahead and display the exercise schematic so that way we can establish the correct unit system based off the schematic description. So the first thing we're going to need to do now is change our unit system from IPS to millimeters grams seconds. The next thing we can do is establish our variables in the equations table. We can do this by going to the feature manager tree, selecting equations, right-clicking, and then opening up the equations table. Let's go ahead and define variables A, B, and C, A being 50, B being 50, and C being 120. With all the variables inputted, close out the equations table. The last thing we need to do before we begin modeling is assign the material based off the schematic description. To assign the correct material, we need to go ahead and right-click on Material in the Feature Manager tree, and then in the search bar we can go ahead and type in 6061 alloy. From here we can go ahead and select the corresponding material and verify the mass density. As we can see here, the mass density is going to be a different value than the one in the schematic description. However, this is just because the units are different. However, these two numbers in reality are equivalent to one another. Now let's go ahead and press apply and then close out the material tab. And we can go ahead and verify that the material was applied correctly by referencing the feature manager tree and seeing the 6061 alloy as the material. And now we can get started modeling. Now that we have the SOLIDWORKs file set up correctly, we can go ahead and activate the standard view planes. We can do this by selecting each plane and then pressing the eyeball button from the feature manager tree. And then going into the isometric view, we can go ahead and select the front plane and press sketch. Following the same process from the previous video, we're going to create a raw stock and then perform extrude cuts to remove material so that way we can get our desired geometry. To create the raw stock, we're going to be using the rectangular tool. Since we know that the origin is going to be in the middle of the part, I'm going to go ahead and begin the rectangle on the left side of the right plane and then just drag outward like this. And now I'm going to go ahead and use the Smart Dimension tool so that we can dimension the height and the length of the part. Starting with the height, we're going to set this as variable B, press the check mark, and then we're going to select the length, and then we're going to set this as variable C. Now that we have the height and the length established, we need to tell SOLIDWORKs that the origin of the part needs to be half of the length. To do this, I'm going to set another dimension between the left edge of the part and the right plane. And then this dimension is going to be half of length C. So I'm going to type variable length C divided by 2. With these 3 dimensions, the sketch is now complete, and we can go ahead and press the check mark in the Feature Manager tree, or press the check mark at the top right corner of the sketch window. Now with our sketch still highlighted in the Feature Manager tree, as we can see here, we're going to go ahead and go to Basic Modeling Features, or you can do this in Features as well. Now we're going to go to Extrude Boss Base. Now that we are in the Extrude feature, we can see that the default value for an extrude is 10 millimeters. And the default setting for the direction is bind. However, again, since our origin is at the center of the material, or center of the part, along the width and along the length, we have already established that the raw stock's origin is already half of the length. Now we need to establish that the origin is also going to be half of the width. To do this, we are going to switch the setting from bind to midplane. Once we do that, we can go ahead and type in the variable A for the length, and now we can go ahead and press the check mark in the Feature Manager tree, or again, the check mark at the top right of the active window. Now that we have created our raw stock, I'm going to go ahead and disable the standard view planes, or default view planes, and return to the isometric view. The next step is to begin creating the sketch for the extrude cuts, that way we can achieve our desired geometry. Based off the schematic, it is my preference to begin the extrusions with a sketch that starts on the front face of our raw stock. So I'm going to go ahead and select the front face, and then press sketch. And from here, I'm going to go ahead and sketch 4 rectangles, and then give them dimensions so that way we can achieve our desired geometry. We will be performing an extrude cut on the left of the raw stock, on the right, towards the bottom, and towards the top, as such. Now before we begin dimensioning any of the lengths of these rectangles, with Smart Dimension, I'm going to go ahead and establish a relation between the left and right sketches, since they are both going to be at the same height from the bottom of the raw stock, indicated by the 10 millimeter length in our schematic. So by clicking the bottom edge of the left rectangle and clicking the bottom edge of the right rectangle, while holding Control or Shift, we're going to see a little menu pop up, and from here we're going to go ahead and select Collinear. This is going to tell SOLIDWORKs that these 2 lengths are going to be at the same height with respect to one another. So now using the Smart Dimension tool, if I dimension the bottom edge of this right rectangle from the bottom of the raw stock and given it a value of 10 millimeters, the bottom edge on the left rectangle will also be a distance of 10 millimeters from the bottom of the raw stock. Now, I'm going to go ahead and dimension this length here to be 20, following the schematic. And then I'm going to go ahead and establish the length of this rectangle to be 40. And I'm also going to need to establish that the midpoint of this rectangle is going to lie on the origin of the part. To do this, I'm going to go ahead and perform the same technique we used earlier. By selecting the right edge of the rectangle, this can also be done using the left edge, I'm going to select the edge, and then select the origin of the part, and then I'm going to establish this dimension to be half of the length, 40. Lastly, all we need to do is dimension the height of the left and right rectangles, and then establish the dimensions for the top rectangle. Following the schematic, the dimension between the left and right rectangle is going to be 70. And since we know this part is going to be symmetric about the origin, this determines that the length between this left edge of the right rectangle to the origin is going to be half of 70 millimeters. Lastly, for this top rectangle, the length is going to be 30 millimeters and the height is going to be 10 millimeters, following the schematic. Applying the same technique used earlier, we're going to establish that this rectangular sketch is also going to be symmetric about the origin. Hey everyone, while editing the video I realized that I made a mistake in the tutorial. Not necessarily as like a fatal mistake, but it presents a different perspective on how to solve this problem, or how to complete the exercise. So I would like to go ahead and point out that mistake right now by mentioning that the schematic doesn't use the dimension 35 millimeters. So technically, by the schematic, description using this dimension is incorrect. However, using the 35mm dimension will yield the exact same answers that the textbook provides. Using this dimension is just one of the many ways that you can solve this problem or create this part. If you decide not to use the 35mm, what you would end up doing, as I'm about to show in the video, is by dimensioning the length between the top rectangle and right rectangle, and you will set this dimension as 20mm. I do include this dimension, however I set it as a reference dimension. Now if we go ahead and select the left edge of the right rectangle and the right edge of the middle rectangle, we can go ahead and set this dimension, which is already determined to be 20mm, and the moment you press the left mouse click button, this message is going to pop up. This error message is asking you if you want to make the dimension that you just established a driving or driven dimension. For our purposes, we will be making it a driven dimension. This means that if we alter any of the dimensions that we have already established, it will automatically change this dimension, and it is simply a reference number, telling you that the length between these two edges will be this value based off the values that you input for the other dimensions. With all these dimensions established, we have completed the sketches for our first extrude cut feature. We can go ahead and press the check mark at the top right of the active window. With the sketch still highlighted, we're going to be going into the basic modeling tools and selecting extrude cut. As we can see, the default input for the length of our extrude feature is going to be the same for the previous value inputted for the previous feature. Going into the isometric view, we can see that establishing a 50mm bind cut from the front face will yield the same result as if we were to do a through cut up until a specific surface or a through all cut. It is important as you are beginning your modeling journey to establish good habits when creating different kinds of features. For cut extrude features, it is generally good practice to do a through all cut or cut up until a specific surface. For this reason, I will be switching the direction from bind to up until the back face of our raw stock, even though that using a 50mm bind cut from the left face will yield the same result. With these settings established, this now completes the first extrude cut feature for this exercise, and we can go ahead and press the green check mark in the feature manager tree or the green check mark at the top right of the active window. The last thing we need to do now is create one more extrude cut feature. To create this extrude cut feature, we will be selecting this face to create our sketch. With this face selected, we will then be using another rectangle sketch to create the geometry for the extrude cut feature. Following the schematic, the height of the sketch is going to be 20mm. And we know that the width from the right edge of the sketch to the back face of our raw stock will be 10mm. And it will be the same for the left edge of our rectangular sketch to the front face of our raw stock, as defined by the schematic. With these dimensions established, this now completes the last sketch for our last extrude cut feature. We can go ahead and press the check mark and move into the extrude cut feature. Since the same settings transferred over from the previous extrude cut feature, all we need to do now is select the correct surface for how deep this cut will go through our part. With the correct surface selected, we can go ahead and complete this feature by pressing the check mark. Now that we have completed the modeling process for this exercise, the last thing we need to do is verify the results. To do this, we need to activate the Mask Properties pop-up window. First we go to Tools, and then we scroll down to Evaluate, and we go and select Mask Properties. From here on out, I will just be using my keyboard shortcut Shift-Z to activate this window. Now that we have the Mask Properties table open, we can go and compare these results to those from the textbook. As we can see here, the mass aligns exactly at 302.4 grams. Next, we can see that the volume also matches at 112,000 cubic millimeters. We can also see that the surface area matches at 26,200 square millimeters. And lastly, we can see that the center of mass in millimeters also matches, where x is 0, y is 19.20, and z is 0. Now that we have verified our results, this exercise is now complete. If you would like, you can go ahead and save the model, give it a name, save it to a place you'll remember in case you ever need a reference back to it. And if you like as well, we can go ahead and change the color so that way it matches the part that we saw at the beginning of the video. To do this, we select the little beach ball at the top right of the feature manager tree. We go ahead and press the arrow to reveal the drop-down menu for the part, and then we right-click on the part. You then click on Edit Appearance. It'll bring us to this view, and from here we just go ahead and select a color of your choice. I'm gonna go ahead and select red, and then we just press the green check mark at the top of the Feature Manager tree. And with that, this completes episode 5. And that wraps up this lesson in the Easy Engineering SOLIDWORKs 101 beginner course. If you're following along with this course, I recommend continuing in order so each lesson builds on the last. If you're interested in learning more about SOLIDWORKs or other engineering courses, feel free to check out the rest of the channel where I talk about tough concepts through tutorials, animated videos, and work example problems in the same clear, fundamentals first approach. Thank you for watching. I'll see you in the next video.